Hi there. If you've been hearing about quantum computing, you've probably heard the term quantum state. It sounds like something out of a sci-fi movie, but it's actually the most fundamental concept you need to understand to grasp how these futuristic computers work. Today, I'm going to explain exactly what a quantum state is, and I promise, we're going to do it using something as simple as a coin. To understand the quantum world, we first have to look at the computers we use today, like your laptop or smartphone. These are classical computers. In this world, everything runs on bits. You can think of a bit like a light switch. It is either on or it is off. It's definite. It's stable. It's one or the other. Let's replace that light switch with a coin. If I place a coin on the table, it's either showing heads or tails. If I ask you, what is the state of this coin? You would say, it's heads. That is a classical state. It's 100% certain. But now, let's enter the quantum world. Imagine I take that same coin and spin it on the table. While it's spinning, if I ask you, is it heads or tails? What would you say? You can't say it's just heads, and you can't say it's just tails. It's in a dynamic mix of both at the same time. This spinning motion, that is the quantum state. In quantum computing, we use qubits instead of bits. And just like that spinning coin, a qubit can exist in a state of superposition. The quantum state is a mathematical description of that spin. It doesn't tell us it is a 1. It tells us the probability. For example, a specific quantum state might tell us, hey, if you stop this coin, there is a 70% chance it will land on heads and a 30% chance it will land on tails. It captures that potential before it lands. Scientists actually have a map for this called the Bloch sphere. Imagine a globe. The North Pole is 0 and the South Pole is 1. A classical bit can only live at the very top or the very bottom. But a quantum state? It can be an arrow pointing anywhere on that globe. It could be on the equator or tilted slightly north. That arrow represents the complex information of the qubit, describing exactly how it's spinning between 0 and 1. Here is the final catch. You can't keep the coin spinning forever. Eventually, you have to look at the result. In quantum mechanics, when we measure the qubit, we essentially slap our hand down on the spinning coin. We force it to choose. It collapses from that complex quantum state into a boring, simple classical state, either a 0 or a 1. So, simply put, a quantum state is that magical, complex moment of spinning potential before we measure the result. I hope that helps you visualize the quantum world. If you want more simple breakdowns like this, make sure to like and subscribe. See you in the next one.